Trace a single line of latitude across a globe, starting in the temperate landscape of London. Follow that line due east as it cuts across the cold center of Russia, deep into the permafrost of Siberia, where winter can kill an unprepared traveler in a single night. Continue across the ocean to the southern edge of Hudson Bay in Canada, a landscape locked in ice for most of the year. Every point along this line sits at the exact same distance from the equator, yet they exist in entirely different worlds. By the standard laws of geography, London should share the brutal climate of Siberia, but it does not. Push this spatial paradox further, and the anomalies multiply. Norway, filled with active fishing towns and modern cities, shares its latitude with the southern tip of Greenland, an uninhabitable frozen wasteland. Stockholm lines up with the empty, sub-zero wilderness of southern Alaska. By all rights, northwestern Europe should be a frozen tundra for half the year, home to a fraction of its current population, its cities non-existent, and its fields incapable of producing food. This massive disruption of geographic rules is not caused by the land, the mountains, or the soil. The answer lies entirely in the water. For millennia, a vast moving river of warmth has pumped tropical heat across the Atlantic Ocean basin. Picking up energy in the Gulf of Mexico, it runs up the coast of North America and discharges its thermal cargo into the northern atmosphere, providing northwestern Europe with a permanent structural shield against a glacial climate. The scale of this planetary heat engine is almost incomprehensible. The system moves roughly 1 petawatt of thermal energy, a number equal to 50 times the combined power consumption of all human civilization, including every engine, factory, power plant, and furnace on Earth. Yet because this machine operates silently in the deep background of human history, modern societies were built directly on top of it without ever acknowledging its structural limits. That period of stability has ended. A rigorous analysis of geophysical data reveals that this oceanic conveyor belt is now running slower than at any point in the last 1600 years. The last time the system moved this sluggishly, the Western Roman Empire was in its final collapse. Every kingdom, cathedral, industrial revolution, and modern war has occurred within a brief historical window when this current was uniquely strong and stable. Today we are forcing our global civilization to rely on a heavily depleted system, entering entirely uncharted territory. For decades, researchers tracked these changes using the oceanographic instruments of the Rapid Array at 26 degrees north, alongside sediment cores pulled from the Atlantic floor. These physical records proved a steady decline, but raw strength alone could not reveal how close the current was to total failure. This year, the scientific landscape shifted fundamentally. By running a massive high-resolution climate model with 10-kilometer grid boxes on the Snellius supercomputer, researchers managed to read the internal warning signals of the ocean. The diagnostic dashboard has lit up. The conclusion is not a statistical forecast or a distant projection, but a direct physical measurement. We are currently living inside the early stages of the system's pre-collapse sequence. The mechanism driving this planetary machine is a delicate self-reinforcing feedback loop balanced on two invisible properties, temperature and salinity. As warm water moves northward, it surrenders its heat to the cold Arctic air, causing it to contract and pack tighter. Simultaneously, intense evaporation leaves behind concentrated salt, increasing the water's density until it becomes heavy enough to lose its argument with gravity. Off the coast of Greenland, this dense water plunges kilometers straight down into the pitch-black abyss, forming massive convective chimneys that act as the primary motor for the entire global conveyor belt. This deep cold water then crawls southward along the seafloor, drawing more warm water up from the tropics to replace it. However, this Elliott self-reinforcing loop is highly vulnerable to a single point of failure. Right now, the second largest mass of ice on Earth is melting at an accelerated pace, pouring hundreds of billions of tons of fresh water directly into the North Atlantic sinking zones. Fresh water is light, not dense. By diluting the salt content, this massive runoff strips the Northern Ocean of its weight, making the surface water too light to fall. The implications of this dilution are systemic. A weaker current brings less salt from the tropics, making the north even fresher, which in turn weakens the current further. A feedback loop does not care which direction it amplifies. It will accelerate a collapse just as faithfully as it maintained an equilibrium. History demonstrates that this cliff is entirely real. During the Younger Dryas 12,900 years ago, a similar pulse of fresh meltwater shut down the current, plunging the hemisphere into a brutal winter that lasted over a millennium. The crucial question is no longer whether the system is changing, but where the invisible threshold sits. A self-reinforcing loop remains stable right up until the moment it reaches its structural limit, maintaining an illusion of normalcy before failing abruptly. The speedometer has confirmed a historic deceleration, but the true margin of safety remains unmeasured. How much fresh water can the engine absorb before the ball rolls over the crest of the valley, reversing the feedback loops entirely and forcing the primary climate regulator of the northern hemisphere into an irreversible, sudden collapse? To diagnose a system of this magnitude, measuring the raw velocity of the water is fundamentally insufficient. For over 20 years, the rapid array has functioned as a highly precise planetary speedometer, tracking the physical volume of water crossing 26 degrees north. Yet, a speedometer cannot distinguish between a vehicle gently slowing down on a clear highway and one braking because its engine is experiencing a catastrophic mechanical failure. It registers the decline but leaves the windshield entirely painted over in black. The true breakthrough achieved on the Snellius supercomputer was the discovery of a physical fuel gauge hidden in plain sight within the structural architecture of the ocean itself. The Gulf Stream does not navigate blindly across the open Atlantic. Its precise geographical path, the exact point where it peels away from the North American coast and strikes out toward Europe, is anchored from below by the immense cold return flow crawling south along the deep ocean floor. This deep, dense current exerts a continuous rotational force that pins the surface current in its historical position. When the overturning circulation weakens, the deep current slows, its physical grip on the surface water loosens, and the Gulf Stream begins to drift. The model demonstrates that as the system loses its internal structural integrity, the Gulf Stream shifts its position northward by a precise margin of 53 kilometers. This geographical displacement is the definitive signature of a depleted energy reserve. It is a direct indication of how much wall is left in the regulatory valley before the system tips into an alternate stable state. The deconstruction of this mechanism exposes the critical flaw in superficial interpretations of climate data. A common myth suggests that a giant sluggish geological system must fail slowly, providing decades of clear, linear warning signs. Physical laws dictate the exact opposite. Because the overturning circulation is a self-reinforcing feedback loop, its behavior approaching a tipping point is highly nonlinear. The system absorbs stress, masks its internal deficits, and maintains a deceptive illusion of stability right up to the edge of the cliff. The gradual weakening that superficial analysis treats as a manageable, long-term trend is actually the standard mechanical prelude to an abrupt collapse. Devoid of a functional fuel gauge, the last push that forces the system over the threshold looks completely identical to the first push it effortlessly shrugged off. There is no structural groan, no visible deformation, and no final acoustic warning before the feedback loops run in reverse. When the collapse occurs, the physical consequences cascade rapidly across multiple systemic levels, moving from macrooceanic structures down to microcomponents and the human factor. The destruction of the northern heat shield immediately reorganizes the global energy budget. Without the continuous delivery of that 1 petawatt of tropical thermal energy, regional temperatures across northwestern Europe drop precipitously, shifting the maritime climate toward a continental deep freeze. Ports that have remained open since the dawn of recorded history lock with ice, halting maritime infrastructure that supports entire modern economies. At the macro scale, the failure is not isolated to the North Atlantic. Because the ocean conveyor is a single globally interconnected machine, a halt in the north puts a brake on the master wheel of the entire planetary circulation. The global thermal gradient shifts, forcing the tropical rain belts to displace geographically and causing major monsoon systems to fault entirely. This planetary reorganization immediately impacts the microcomponents of the ecosystem. In the deep sea, the cessation of deep water formations suffocates the benthic layer, cutting off the vertical transport of oxygen and nutrients that sustains deep-sea marine biology. On land, ecosystems that developed over thousands of years under the protection of a stable climate are exposed to unprecedented thermal stress. The human factor represents the final, most vulnerable link in this cascading chain. Modern civilization is a rigid architectural construct built entirely on the assumption of permanent environmental parameters. Unlike the sparse populations of hunter-gatherers who adapted to the abrupt cooling of the Younger Dryas by shifting their territory, contemporary society comprises 8 billion individuals locked into fixed geographic borders, permanent agricultural zones, and complex global supply chains. The failure of the current directly threatens the agricultural baseline of Western Europe, rendering fields incapable of feeding the populations concentrated around major urban centers. A physical collapse of the AMOC is not an abstract scientific projection, it is a structural limit that redefines the survival capacity of global civilization. The profound danger of a failing overturning circulation lies in its ability to distort our perception of risk, hiding a systemic crisis behind a mask of regional contradictions. A persistent superficial myth suggests that global warming must naturally manifest as uniform heat everywhere on the map. This interpretation collapses under the rigorous laws of thermodynamics and fluid mechanics. In a complex planetary system, global thermal energy does not distribute evenly, it drives currents, and those currents redistribute the heat. When the master wheel of the Atlantic circulation slows, it triggers a profound paradox where planet-wide warming directly causes severe localized cooling. The warming of the atmosphere opens the freshwater tap on the Greenland ice sheet, and that light, fresh runoff chokes the engine that carries tropical warmth to the north. Global heat is converted into a regional deep freeze. This internal contradiction is exactly why the danger is so easily dismissed by uncritical observers. It operates on a scale that defies standard human intuition, masking a major structural crisis behind a deceptive, quiet transition that can be easily mistaken for routine variability. Deconstructing this paradox reveals the staggering fragility of our global infrastructure. The entire architecture of modern northern society is a massive investment built on the unexamined assumption that this oceanic heat shield is a permanent feature of reality, like gravity or the rotation of the Earth. We have treated a highly dynamic, precariously balanced physical circulation as a fixed background condition. If you pull up sediment cores layer by layer from the deep ocean floor, the grain sizes of the mud and the chemical shells of long-dead organisms leave an undeniable record of how this current functions. The historical baseline is clear, but the modern data indicates that the system is entering its failure mode. When the convective chimneys off the coast of Greenland fail to plunge because the surface water has become too diluted and light to sink, the entire global conveyor belt experiences an immediate drop in pressure. The thermal bricks stop arriving at the cold room, and the consequences propagate outward through the entire global network. At the macro level, the collapse of this circulation does not simply lower the temperature of northwestern Europe. It structurally disrupts the entire planetary climate equilibrium. The massive accumulation of thermal energy that can no longer move northward remains trapped in the southern and tropical oceans. This severe distortion of the global thermal gradient forces an immediate geographic displacement of the tropical rain belts and causes critical monsoon systems across Africa and Asia to fault entirely. Millions of square kilometers of agricultural land face sudden, catastrophic droughts, demonstrating that an oceanic failure in the high North Atlantic immediately threatens the water security of populations thousands of kilometers away. On a micro scale, the termination of deep water formation halts the vertical conveyor belt that drives the chemical cycling of the oceans. The deep ocean floor is starved of oxygen, while vital nutrients remain locked in the dark abyss, unable to rise to the sunlit surface where marine food webs begin. This breakdown of the vertical circulation triggers a rapid collapse of marine ecosystems, destroying the primary protein source for coastal societies. The human factor represents the ultimate point of systemic vulnerability. Unlike historical populations who maintained a fluid relationship with a changing landscape, contemporary global civilization is a highly rigid, hyper-optimized structure. We have built dense urban centers, established fixed national borders, and created brittle, just-in-time global supply chains, all completely dependent on the climate patterns of the last millennium. When these patterns fail, our structural rigidity prevents rapid adaptation. The sudden loss of agricultural viability in formerly temperate zones cannot be solved by simply moving populations or altering trade routes. The sheer velocity of an abrupt climate shift, matching the rapid multi-decadal flip observed in the geological record of the Younger Dryas, outpaces the structural response time of modern political and economic systems. The diagnostic warning lights are completely real, well-understood physical measurements. The line we hoped we would never cross is already behind us, and the system is steadily sliding toward its structural limit. The systemic breakdown of the ocean circulation exposes the final, most dangerous misconception of modern risk analysis: the illusion that global critical infrastructure can be repaired after it crosses a threshold of structural failure. In conventional engineering, a compromised mechanism can often be isolated, deactivated, and retrofitted. In geophysical systems operating on a planetary scale, the concept of a post-tipping recovery is a physical impossibility. The sheer momentum of an ocean current carrying 80 million cubic meters of water per second cannot be counteracted by any technological intervention within the capacity of human civilization. When the feedback loop shifts into reverse, the process becomes entirely self-sustaining. The open tap of the Greenland ice sheet continues to release hundreds of billions of tons of fresh water annually, driven by the background thermal energy already locked into the global atmospheric system. The dilution of the northern seas progresses past the point where deep water formation can occur, locking the entire Atlantic basin into a permanent state of stratified stagnation. To evaluate this crisis through the lens of hard systems logic is to recognize that we are observing the structural failure of a master regulatory wheel. The physical interconnectedness of the global ocean ensures that the impact scale rapidly from macro-geophysical shifts down to the microscopic foundations of the biosphere, ultimately colliding with the extreme rigidity of the human factor. At the macro level, the cessation of the overturning circulation permanently alters the sea level architecture of the planet. When the northward flow of water stalls, the massive volume of liquid that was previously pulled toward the high latitudes by the sinking action of the convective chimneys begins to pile up along the eastern seaboard of North America. This dynamic regional sea level rise occurs independent of global ice melt calculations, forcing water directly into low-lying coastal infrastructure, rendering highly populated urban corridors permanently uninhabitable. Simultaneously, the microcomponents of the ocean engine undergo a terminal transformation. The lack of downward plunging water off the coast of Greenland cuts off the deep ocean ventilation system. Without this vertical physical transport, the oxygen levels in the dark abyssal currents plummet towards zero. This expansion of deep-sea anoxic zones deconstructs the biological framework of the ocean, permanently halting the nutrient upwelling cycles driven by the winds of the Southern Ocean. The microscopic planktonic communities which form the absolute baseline of the global carbon cycle and the marine food web lose the chemical inputs required for survival. The resulting collapse cascades upward through every trophic level, systematically decimating global fisheries and erasing a primary protein reserve upon which billions of people rely. The human factor undergoes the most severe structural compression in this sequence. Modern industrial civilization operates as a hyper-optimized, low-margin system that derives its efficiency from extreme specialization and geographic permanence. Every city, deep-water port, agricultural baseline, and political boundary was drawn under the absolute assumption that the climate map of the past 1600 years was immutable. When the tipping point is breached, this geographic permanence becomes a fatal vulnerability. The rapid cooling of northern Europe, combined with the failure of seasonal monsoons in the southern hemisphere, completely destroys the predictability of global food production. In a world of 8 billion individuals, agriculture cannot simply migrate across borders to track moving climate bands. The geopolitical borders are rigid, the infrastructure is fixed into concrete, and the food storage reserves are measured in weeks, not decades. The structural failure of the current does not merely alter weather patterns. It directly fractures the economic and logistical links that prevent modern societies from collapsing into localized chaos. The data extracted from the deep ocean mud and processed by the Snellius supercomputer is not an academic exercise in climate modeling. It is a structural assessment of a critical global barrier that has already begun to give way. The warning signals are no longer speculative projections for a distant generation. They are real-time measurements of an active, unfolding geophysical collapse. The realization that the ocean conveyor belt functions on a 1,000-year cycle exposes the ultimate illusion of human management, the myth that our economic and political timelines hold any relevance to the structural limits of the planet. A single parcel of water dropped into the tropical Atlantic takes a millennium to complete the full circuit, creeping across the floor of the world before being drawn upward by the fierce winds of the Southern Ocean. This immense, slow-moving apparatus operates on a scale that completely transcends the short-term focus of human societies, which measure stability in quarterly financial cycles, annual crop yields, or multi-year political terms. We built an entire modern civilization on top of this geological engine, mistaking its massive inertia for absolute permanence. Because the current changes so gradually, losing only a fraction of its structural velocity each decade, it has failed to trigger the immediate reactive alarms of human governance. This silent deceleration represents the most dangerous structural vulnerability of our time, an existential shift occurring too slowly to register in the news of the afternoon, yet too powerful to be reversed once the final threshold is breached. Deconstructing this temporal mismatch reveals the hard physical boundary where human optimization collides with planetary mechanics. The high-resolution model run on the Snellius supercomputer has confirmed that the system is not settling into a polite, predictable decline, but is actively burning through its structural margins. When a self-reinforcing feedback loop approaches its tipping point, the gradual changes observed over centuries give way to an abrupt, nonlinear reorganization of the entire global energy budget. The historical record of the Younger Dryas indicates that when the freshwater tap-off Greenland dilutes the salt content past a critical value, the convective chimneys halt, and the planetary heat shield vanishes over a span that can be as short as a few decades. This rapid multi-decadal flip represents the real boundary of the system under examination. It is a strict architectural limit that defies the capacity of modern institutions to adapt, prepare, or recover. At the macro-geophysical level, this rapid disruption locks the northern hemisphere into a severe continental deep freeze, while permanently altering global rainbelts and monsoons. On a micro scale, the vertical stagnation of the water column starves marine life of oxygen and permanently breaks the nutrient cycling that forms the baseline of the global biosphere. The cascading failure culminates directly in the human factor, where a hyper-specialized global society comprising 8 billion people is exposed to a sudden, permanent loss of its environmental baseline. We have built a world of fixed geographic infrastructure, rigid borders, and low-margin agricultural zones, entirely dependent on a climate pattern that is now coming apart. If the food production zones of Europe freeze and the monsoons of the southern hemisphere fail simultaneously, the complex logistical supply chains that keep modern cities alive will experience an immediate terminal fracture. There are no engineering interventions, no carbon credits, and no economic adjustments that can restart an ocean current, moving 50 times the energy of human civilization once its physical engine has stalled. The scientific instruments of the rapid array and the 30 years of gathered satellite data have removed the luxury of speculation. The warning lights on the dashboard are not a forecast for a distant future. They are an unyielding measurement of our current position. The line we hoped we would never cross is already behind us. The core mechanism that kept the entire northern hemisphere livable for the whole span of recorded history is actively breaking down. And the only question left is how much time remains on the other side of the threshold.